everybody. This is going to be a solution to problem 1.12.16 in our collaborative statistics book. In it, you've got data points that look like how many years to the nearest year 19 immigrants have lived in the U.S. They give us a raw list of data. I went ahead and put it over here in order. It makes it a little bit easier to see the data when it's in order. This is the table they've given us in the text. And the first thing it says to fix the errors in the table. Okay, so as you kind of scroll down, look at the raw data and look at the organized data over here in the table. Everything jibes until you get down to here. You'll notice there are two 15s and two 20s. So, and these are both indicated as 1. And then this is easy to miss, but when you look over to the relative frequency table, which is the percentages, right now these sum up to 17/19, and these frequencies sum up to 17. But according to them, they have to sum up to 19, and double checking, you've got 6 plus 5 is 11, plus 4 is 15, plus 4 is 19. So we're missing 2 data points, and here's where they are right here, if you check them out. So the fixes are going to be, let's fix those and make those 2s each. Let's fix these, make these 2s each. And then I'm guessing the cumulative frequency, I haven't talked about this much in class, but I think you can get the idea. The idea is this is a percentage of not just this data point, but also all the data points below's relative frequencies. So basically, this 26.32% represents the sum total of all the relative frequencies of 2 and 0. 31.58% is the sum total of 4 and below, which will be 1/19, 3/19, and 2/19, 6/19. So the sum of this has to be 100%, because 100% of the data is 20 or below. The question is, are these messed up? Is this percentage messed up? This one is most definitely not. He's fine. Is this one messed up? Well, I'm not the best with 19th fractions. If that was 1/20th, 1/20th is about 5%. So I'm going to go ahead and use about 5% as an ish for this. And if you want more precision, of course, use a calculator. And it looks, yeah, if you look from here to here, it looks like it jumps about 5.2%. So since we were off by 1 down here, I'm going to add about 5.2% to this and call this 89, sorry, working out loud. I'll call it about 89%, 89.41%. And then if I have to add that same amount again, yeah, that's going to work out just about right. Just about right. If I have to add 5.2 twice, it's like 10.4, which is essentially going to get me up to 100%. If you need more precision, by all means, go grab a calculator. Okay, so now the numbers are ish correct. Explain how someone might have arrived at the incorrect number or numbers. Well, that's probably just a quick little tally error. If you don't put them in order, like I did over here, it's going to be really easy to miss what's going on. And I mean, you look at a data table, unless you're checking the sum of the frequencies or relative frequencies versus what you know the raw data is, you might miss that. So that's nice. This can be remedied, of course, by using computer software versus a manual count, but sometimes you have to do a manual count. It says, explain what is wrong with this statement. 47% of the people surveyed have lived in the U.S. for 5 years. 47% of the people surveyed. Oh, sorry, I also missed an error. I missed an error in there, didn't I? That 15% right there is incorrect. This guy is incorrect. 15.79% is going to be exactly 3/19. And I'm glad they mentioned this problem. I wouldn't even have noticed that. So I think the 47% that they're talking about is going to be right here, which would be the sum of the 3/19, 1, 3, and 2. So that's going to be 4 9/19, which is just going to be just shy of a half. And that's what this is, just shy of a half. Whew, apologies. What's wrong with that statement is that the 15% that was there is the percent of those that have lived in the U.S. for 5 years. That indicates that 15% have lived for 5 years. 47% have lived in the U.S. for at most 5 years. So, see the difference there? Exactly versus at most. Cool? All right. Part C is fix the statement above to make it correct, which we just did. D, what fraction of the people surveyed had lived in the U.S. for 5 or 7 years? Here's 5, here's 7. 5 is 3/19, 7 is 2/19, so that's 5/19, which, again, 19ths is a weird fraction. If we make 1920, it's 5/20 or 1/4, 25%. 5/19 will be a little bit above that. What fraction, if the people surveyed have lived in the U.S. at most 12 years? At most 12. Well, here's 12. At most 12 means 12 or less, no more than 12. So that would be the 79%-ish. But they're asking for fraction, right? So the fraction would be the sum of all these fractions. But here's a cool trick you can do. We know that this sums up. The sum of that relative frequency column is 19/19, which sums to that 1 that's right there. We need to get 12 and down. Well, above 12 is 4/19, which means that the remainder has to be the 15/19, the remainder. So there's a shortcut you can do. If you know the whole thing sums to 1 and you need to add up a big chunk of that, take away that what you don't need and what's left behind is what you do. We'll visit that idea quite a bit in this class. What fraction of the people surveyed have lived in the U.S. fewer than 12 years? So that's different than at most 12. At most 12 includes 12. Fewer than 12 does not include 12. It includes all those below. So that would be take 6 off of 19 to get 13/19. And then what fraction of the people surveyed have lived in the U.S. from 5 to 20 years inclusive? So that would be all these folks here. So I've got to add these up, but I can use my same trick and take the 6/19 off the 19/19 to get 13/19. So there you go, working your way around a frequency table, relative frequency table, and a cumulative relative frequency table.